A very good morning, Monica. Today we are going to see on the topic of the basic statistical analysis on a data analytics and automation system. So I am Karthikeyan from Department of Mechatronics Engineering, working at SNS College of Technology. So statistical analysis is basically the science of collecting, understanding, interpreting, and presenting data so that we can discover useful patterns and trends. So why should we, as automation engineers, care? Because raw sensor data, production logs, quality measurements, or predictive maintenance readings are just numbers until we apply statistics. Statistics turns that raw data into actionable insights that help us make better decisions, improve quality, reduce downtime, and optimize the process. So we will cover the most important foundational concept today in the upcoming slides. So the types of data. First thing, not all data is the same. So we mainly divided into two big families. There is categorical, qualitative, things like mission status. So running, ideal, or fault or defect type. So under numerical data, that is quantitative, that is actual measurements. This splits again into discrete, that is countable integers, number of rejects per batch, or number of cycles completed. The next one will be the continuous, can take any value within a range. Temperature, pressure, vibration, amplitude, and current in milliamps. So understanding this difference is very important because it decides which statistical tools we can use for the particular application. So how we can measure the central tendency? So let's look at how we describe the typical or central value of data set. So the so-called measure of central tendency. So what is mean? What most people call the average, add everything up and divide by count. Very sensitive to extreme values. The next one will be median. Arrange all values from the largest to smallest, the middle one. Much more robust when we called outliers. Very common in the real sensor data. And the mode, the value that appears most often. Useful for the categorical data or when we want to know the most common fault type. And the quick rule is symmetric data without the outliers use as mean. Skewed data or outliers present, we prefer median. We want most frequent category, that is mode. So the measures of dispersion comes under central tendency tells us where the data is centered, but how much it's spread out. That's where measures of dispersion comes in. So the simplest one, that is the range, max to minimum, easy, but very sensitive to single bad readings. So better the variance, average square distance of each point from the mean. The standard deviation is the square root of variance, same unit as the original data. So much easier to interpret. For example, if temperature standard deviation is 2.1 degrees Celsius, the most readings are within roughly plus or minus 4 to 6 degrees Celsius of the mean. Higher the standard deviation equals more variability equals usually more precise instability, and followed by the probability distribution. Now we have to the describe how likely different values are. The most important one in practice is the normal distribution, the famous bell curve, symmetric defined by mean mu and standard deviation sigma. So you should remember the 68, 95 to 99.7 rule, that is the empirical rule, that values vary from not equal to 68 percentage of values lie within plus or minus 1 sigma, then 95 percentage within plus or minus 2 sigma, and 99.7 percentage within the values of plus or minus 3 sigma. This rule is used everywhere in the control charts, capability analysis, and setting alarm limits. So we also meet the binomial distribution very often. For example, each produced part is either okay or defective. There will be two outcomes, and we test in the paths. And the followed by the hypothesis testing, one of the most powerful tools. We always start with two competing statements. Null hypothesis, H naught, the boring or default assumption, no difference, no effect, and the process is stable. Alternative hypothesis is H1, what we suspect or want to prove. So we collect the data and calculated a p-value, the probability of seeing data as extreme as ours, if H0 is actually true. So the common decision rule is if p-value is greater than or equal to 0.05, reject H0. We call the result statistically significant. If a p-value is greater than 0.05, fail to reject H0. So example we can use, did the new controller tuning reduce average cycle time compared to the last month? So followed by the correlation and regression. Very often we want to know, does variable A influence the variable B? So correlation measures the strength and the direction of the linear relationship. That is plus 1 is perfect positive, 0 is no linear relationship, and minus 1 is perfect negative. But remember, correlation is not equal to the causation. So when we want to predict, we use regression. Most commonly simple linear regression, that is eta, which is equal to beta naught plus beta 1x plus error. The line of the best fit minimizes squared errors. In automation, we use this for soft sensors, predicting the quality for easy to measure variables, energy consumption models, etc. And here I have included a couple of mind maps to help you see the big picture. So all these concepts are connected to central tendency plus dispersion to describe data, to find the probability distribution, to find the model behavior, and to the hypothesis testing, through which we can able to make decisions. By making the decision, we can correlate and regression it to find the relationship between the uh, generated data. I strongly recommend creating your own mind map. It helps a lot during revision. So let us take a quickly recap the key takeaways. So the statistical analysis is the bridge between raw data and meaningful business or engineering decisions. Today we covered types of data: mean, median, mode, range, variance, standard deviation, normal and binomial distribution, empirical rule, hypothesis testing, and p-value, correlation, and regression. So in automation and manufacturing, these tools directly support statistical process control, quality improvement, predictive maintenance, and the process optimization. So masters the basics, the more advanced machine learning topics later in this course. So much easier to understand. So that brings to the end